Imagine biting into a juicy red tomato. You savor its sweetness. But this is no ordinary tomato. This tomato was grown on Mars. The idea of eating fresh food on Mars is no longer science fiction. It's a goal that scientists are actively working towards. And it's not just about the taste. Fresh food is crucial for the physical and mental health of astronauts. It's a reminder of home, a symbol of life thriving in the harshest of environments. Growing food on Mars is a giant leap towards establishing a permanent human presence on another planet. It's a testament to human ingenuity and our drive to explore the unknown. Mars is a tough place to grow anything. The red planet presents a myriad of challenges that make traditional farming methods nearly impossible. It's cold, dry, and bombarded by radiation. The harsh environment is unlike anything we experience on Earth. The atmosphere is thin, and the soil is toxic. The lack of a protective atmosphere means that harmful cosmic rays and solar radiation constantly bombard the surface. The average temperature on Mars is a frigid -62 degrees Celsius, which is about -79.6 degrees Fahrenheit. These extreme temperatures pose a significant challenge for any form of life that's cold enough to freeze water instantly. Any liquid water on the surface would quickly turn to ice, making it difficult for plants to access this vital resource. And the thin atmosphere offers little protection from the sun's harmful radiation. Without a thick atmosphere to shield it, the surface is exposed to intense levels of ultraviolet radiation. Martian soil, known as regolith, lacks the essential nutrients that plants need to grow. The soil is not only barren but also contains elements that are toxic to most Earth-based life forms. It also contains perchlorates, toxic chemicals that are harmful to humans. These chemicals would need to be removed or neutralized before any farming could take place. These challenges might seem insurmountable. The combination of extreme cold, radiation, and toxic soil creates a hostile environment for agriculture. But scientists are developing innovative solutions to overcome them. Researchers are exploring advanced techniques such as hydroponics and aeroponics, which don't rely on soil. The dream of Martian farms is becoming increasingly realistic. With continued research and technological advancements, the vision of thriving farms on Mars could one day become a reality. Greenhouses and controlled environment agriculture are being designed to create habitable conditions for plants. These structures would protect crops from the harsh Martian environment. Extracting water from the Martian ice caps and underground reservoirs is another critical step. This water can be purified and used to sustain both human life and agriculture. Scientists are also working on nutrient solutions to enrich the Martian soil or replace it entirely. These solutions could provide the necessary minerals and nutrients for plant growth. Solar energy will likely play a significant role in powering these agricultural systems. Mars receives ample sunlight, which can be harnessed to generate electricity for farming operations. As we look to the future, the possibility of human settlements on Mars becomes more tangible. Sustainable farming will be a cornerstone of these colonies, ensuring a steady food supply for inhabitants. The vision of a thriving Mars with successful agriculture and human colonies is no longer just a distant dream. It is a goal within our reach, thanks to the relentless efforts of scientists and engineers. Turning Martian regolith into fertile soil is a major hurdle. The Martian surface is covered with a layer of regolith, which is a mix of dust, soil, and broken rock. This regolith is not only devoid of organic material, but also contains toxic substances like perchlorates, making it inhospitable for plant growth. But scientists are exploring several promising solutions. They are working tirelessly in advanced laboratories, conducting experiments and discussing innovative methods to overcome these challenges. Their goal is to transform this barren landscape into a thriving habitat for plants. One approach is to use bioremediation. This technique involves the use of microorganisms that can break down harmful substances in the soil. By introducing specific types of bacteria and fungi, scientists hope to neutralize the toxic perchlorates and release essential nutrients that plants need to grow. This involves introducing microorganisms that can break down the toxic perchlorates in the soil and release nutrients. These microorganisms can metabolize the perchlorates, converting them into less harmful compounds, and in the process, enrich the soil with vital nutrients. Another strategy is to create artificial soil. This method involves combining Martian regolith with organic matter to improve its structure and nutrient content. Scientists are experimenting with various organic materials such as composted food waste to create a fertile medium for plant growth. This would involve mixing regolith with organic matter such as composted food waste to improve its structure and nutrient content. The addition of organic matter not only provides essential nutrients but also enhances the soil's ability to retain water, which is crucial for plant survival in the arid Martian environment. Researchers are also investigating the use of hydroponics and aeroponics. These innovative agricultural techniques allow plants to grow without soil, using nutrient-rich water or mist to deliver essential minerals directly to the plant roots. These methods allow plants to grow in nutrient-rich water or mist, bypassing the need for soil altogether. Hydroponics involves growing plants in a water-based solution rich in nutrients, while aeroponics suspends plants in the air and uses a fine mist to deliver nutrients. Both methods have shown great promise in producing healthy, robust plants. By transforming the Martian regolith, scientists aim to create a suitable environment for plants to take root and thrive. The ultimate goal is to establish self-sustaining agricultural systems on Mars, which would be a monumental step towards human colonization of the red planet. With continued research and innovation, the dream of growing lush, green landscapes on Mars is becoming increasingly attainable. Water is essential for all life, including plants. While Mars is a dry planet, there are sources of water available. Scientists believe that there is a significant amount of water ice trapped beneath the Martian surface. This ice could be extracted and purified to provide a sustainable water source for crops. Another potential source of water is the Martian atmosphere. Although thin, the atmosphere does contain water vapor. Scientists are developing technologies to extract this moisture and condense it into usable water. By tapping into these water sources, Martian farmers could ensure a steady supply of this life-giving liquid for their crops. Sunlight is essential for photosynthesis, the process by which plants convert light energy into chemical energy. However, Mars receives significantly less sunlight than Earth. To compensate for the lower light levels, Martian farms will need to rely on artificial lighting. LED lights are a promising solution, as they are energy efficient and can be customized to emit specific wavelengths of light that are optimal for plant growth. These artificial suns would provide the necessary energy for plants to photosynthesize and flourish, ensuring a bountiful harvest even in the Martian environment. Not all crops are well suited for the challenging Martian environment. Scientists are focusing on selecting crops that are hardy, adaptable, and highly nutritious. Leafy greens such as lettuce, spinach, and kale are excellent candidates. They are relatively easy to grow and are packed with essential vitamins and minerals. Other potential crops include potatoes, strawberries, and even wheat. These crops have been successfully grown in simulated Martian conditions, demonstrating their resilience. By carefully selecting the right crops, Martian farmers can ensure a diverse and nutritious diet for themselves and future colonists. To maximize efficiency and minimize waste, Martian farms will likely employ innovative agricultural techniques such as vertical farming and closed-loop systems. Vertical farming involves growing crops in vertically stacked layers, maximizing the use of space and resources. This approach is particularly well suited for the confined environments of Martian habitats. Closed-loop systems aim to create a self-sustaining ecosystem within the farm. Water and nutrients are recycled, minimizing waste and reducing the reliance on external resources. These cutting-edge technologies will be crucial for creating sustainable and productive farms on Mars. Beyond the practical benefits, tending to a Martian garden could provide significant psychological benefits for astronauts living and working in the isolated and confined environment of Mars. The red planet, with its barren landscapes and harsh conditions, can be a challenging place for the human psyche. The presence of a garden, however, can transform this alien environment into a more hospitable and comforting space. The act of gardening can be incredibly therapeutic. It allows astronauts to engage in a routine that is both familiar and grounding. The simple act of planting a seed, watching it grow, and nurturing it to maturity can provide a profound sense of satisfaction and normalcy in an otherwise extraordinary setting. It provides a sense of purpose, accomplishment, and connection to nature. These feelings are essential for maintaining a positive mental state, especially when far from home. The responsibility of caring for living organisms can instill a sense of duty and importance, which can be incredibly motivating and uplifting. These factors can be crucial for maintaining mental well-being during long-duration space missions. The isolation and confinement of space travel can lead to feelings of loneliness and depression. A Martian garden can serve as a sanctuary, a place where astronauts can retreat to find solace and peace amidst the rigors of their mission. Imagine an astronaut stepping into a greenhouse filled with the sights, smells, and sounds of Earth. The vibrant green leaves, the colorful blooms, and the earthy aroma can evoke memories of home and provide a comforting reminder of the planet they left behind. This sensory connection to Earth can be a powerful tool in combating homesickness and maintaining a positive outlook. The scent of fresh herbs, the fragrance of blooming flowers, and the rich smell of soil can create a multisensory experience that is both soothing and invigorating. These familiar scents can trigger positive emotions and memories, helping astronauts feel more connected to their roots and less isolated in the vastness of space. The gentle hum of pollinating insects, the buzz of bees, and the flutter of butterflies can add to this sensory experience. These sounds can create a sense of normalcy and continuity, reminding astronauts of the natural cycles of life on Earth. The presence of these small creatures can also enhance the feeling of being in a living, breathing ecosystem, rather than a sterile, artificial environment. These sensory experiences could provide a much-needed psychological boost. The combination of visual beauty, aromatic scents, and natural sounds can create a holistic environment that nurtures the mind and spirit. This sensory immersion can help astronauts relax, reduce stress, and improve their overall well-being. Martian farms could become oases of tranquility and familiarity, nurturing not just the body but also the mind and spirit. These green spaces can serve as a refuge from the harsh realities of space travel, offering a place of peace and rejuvenation. In this way, Martian farming can play a crucial role in supporting the psychological health of astronauts, ensuring they remain resilient and focused throughout their mission.